here it is. Any component, I've kind of alluded to this a few times in our lectures, but a component, every React component has this life cycle that it goes through. I like to think of Simba and Lion King and the circle of life. React has a similar circle of life. A React component has a similar circle of life. There are 3 phases to the React component lifecycle. Who can tell me what those phases are? While you guys are typing, that's not what I wanted. Let's drop this. You have to go past the add. Maybe done. Okay, here you go. Okay, so the lifecycle methods, we have birth, growth, and death, bum, bum, bum. Or, AKA mount, update, and unmount. Yeah, perfect. I love it. Birth, mounting, growth, updating, death, mounting. Nice. Perfect. Yeah, that's great. Mount, ride, and unmount. I like it. So yeah, those are really good ways to look at the different methods of the, or different phases of the component lifecycle. So there is the, as you read today, there's the birth, the growth, and death, or mounting, updating, and unmounting. So mounting would be this phase here, and then the updating phase is here. This is kind of the life of your component, and what happens while your component is mounted on the screen, and then the unmounting phase is what's going to happen when your component gets pulled off of the DOM. There's really only one thing that we're going to do in this unmounting phase, and we'll talk about that in just a minute. The important part, well, that's important too, but the most of your code will happen between these 2 phases, as you can see by the graphic here. Okay, so let's pull this up. We're going to open image in a new tab. And let's talk about this, the life cycle, for a minute. So from what you guys read this morning, what is the mounting phase for? What do we do with the mounting phase, and how does the mounting phase kind of happen, work? Let me go back to this. Yeah, the mounting phase puts the component on the DOM. It's a point that we can start working with asynchronous data when we're loading things. Yep. Component built from the ground up on our, inside our browser here. Perfect. As it mentions, it's the birth of our component. So it's a special time in every component's life where it's built from nothing. Yes, that's amazing. Component will mount before the components render, then first. Good, good. Then you can use state before initial render. Yeah, so that's a really good point. So when we're talking about component life cycles and the how a component is mounted onto the screen, it's really important for us to understand the order that these different functions are going to be called in. And then when we, during the updating phase, when we get new props or we run this.setState, then it's important to know the order that these are going to happen. Okay. So let's talk about the mounting phase. The very first thing that happens when your component starts mounting is the constructor runs. And the constructor is where we're going to set up initial data. There we go, got it. Okay, constructor, we're gonna set up initial data. If we need to, we're also going to bind methods to the this keyword, but we're just gonna use arrow functions to do that instead. So, but this is also a place that can occur. All right, so we've got initial data in our state. We're going to call this our state object, right? This is a pattern that we've seen since the end of last week. We're not going to worry too much about get derive state from props. Render, so then our render happens. Now we know, we're very familiar with, you may not realize it, but you are familiar with this. So looking at our project from yesterday, our app.js, our constructor gets called and sets up our data on our state. Now, after the constructor is called, then the render function happens. So let's go back and look at this code sandbox. If the render function ran before the constructor, we would have no state object and we would get an error right here. So constructor happens first, and then our initial render happens next. And our initial render usually takes in whatever data from state and passes it to whatever components is here. Then this component goes through the same lifecycle methods, and so on and so forth until all the components are built on the DOM. After, and this part's important, after the render happens, after our initial render happens, then we run a function called component.didMount. Now, someone mentioned, let me pull it up here real quick. Someone mentioned that this is where we can work with some async data. And it's on inside component.didMount that we fetch data from an API. The reason, there's two reasons for, well, there's one main reason for this, waiting until after our constructor and after our render and after our component.didMount, that we wait to fetch our data. And the main reason is we want to provide a good user experience for our end users. If we made a call in our constructor for our data from our API, we would not have our initial data, and our render would not look would not work and would not look very good. So if we go here, we wouldn't have data here, and we may get an error, or you may have to spend extra time to solve for the fact that maybe we don't have this data yet. So our constructor has to finish running before we can run render. And if we have to wait for an API call for our constructor to finish running, then our user is going to sit there for maybe even a couple seconds with nothing on the screen. So we want to be able, we don't want to block render from running. And so we don't make a fetch call until our first render happens. And that first render, if we don't have data back from our API, that first render can at least render like a loading message or a spinner or something, right? We see that in apps all the time. You go to an application and you get a little spinner for half a second, and then your data shows up. So without that first render happening before we make our fetch, then we wouldn't ever see that loading message, and we would wonder if this API fetch took 4 seconds, we would probably refresh the page or close the window and never use that app again. It would just be a bad user experience, and we wouldn't want to go back to that website. So the render function, the initial render happens first, then we fetch our data inside component did not. Similarly, inside component did update, we can make other API requests. Or if there's like some user interaction, to click a button, we can make API calls inside our own custom functions in the component. Okay, let's take a look at questions real fast. That is the mounting phase. We condition it on mount so we don't put paint data onto something that doesn't exist. That would be embarrassing indeed. All right, so Julie asks, can you explain pure functions in more detail, i.e. how's a class component to render function pure and returning the same thing each time when it contains a .map based on varying state property, or is it just not what should be? Let's see. That is a good question, because a pure function should not rely on outside data like this. So I wonder, is render a pure function? Okay, let's see. That's not pure functional components. Methods. I don't know if render is a pure function or not. Oh, here we go. Okay, so it returns the same result each time it's invoked if you do not change its inputs, which is the props and the state. If you change the input, then it is possible that it returns a different result. That is still pure function for somewhat loose definition of pure. Pure functions are not allowed to use any state from outside the function, such as this.props or this.state, but React encourages patterns that approximate purity as much as is reasonable, as long as render has no side effects. Okay. Yeah, and Dan says that this is helpful. Hopefully that helps. So this seems like a true statement. Okay. So this is a really good question, and I think it's pertinent to what we're talking about here with the render function and what we've been discussing as far as writing good, clean code in React. I don't want to get too deep into functional programming paradigm right now, but I will explain real quick what a pure function is and how these functions relate to that in a React way based on that answer. So a pure function is a function that takes in some data, and no matter what, if you always pass in the same data, it will always, no matter what, return the same thing. So in other words, it's not ever going to introduce side effects into your data. It's always going to work the same way. You're never going to have anything different as long as you're passing in the same data. So the idea behind it is, by the exact definition, as I mentioned before, a pure function would not rely on something outside of that function itself, like this.state.Pokemon. If this were to be a truly pure function, we would pass in state. We would somehow pass in state and probably props here, and then we would just say state.Pokemon. and then this would make it a truly pure function. What the pure functions are a good habit to get into creating, because you're going to see that pattern in Redux, and number two, you're going to just write better code if you are following that paradigm. Now, with render, since we're talking about lifecycle methods, these methods don't take in, well, the render method doesn't take in any arguments, as we just saw. It actually does rely on some data outside of the scope of this function. So it's not technically pure, as it's kind of a loose definition of pure, but as Jesse here says, it's pure enough for React. So it's a pattern that approximates purity as much as is reasonable. As long as render has no side effects and only calls other pure functions, then it's good enough. So you wouldn't see something like this. This is a way to introduce a side effect into your render function. You would not see this. This would change the data, which would change what's being passed in here. So as long as you're not changing your data from within inside the render function, then it's quote unquote pure enough, yes. Okay, so a little bit of a tangent there, but I think it's a good discussion to have and to start hearing some of these things. Cool. Let's look at component div mount, and let's look at setting data onto for our application inside component div mount. I'm going to clear my drawings. There we go. Okay, so here we've got the project from yesterday. What we're going to do is, well, let's finish talking about updating real quick, and then we'll look at it in the code. Once a component has mounted and we've kicked off our initial data fetch, we're now kind of in this like spinning mode of just waiting for something to happen. Our component is just alive on the screen, waiting for one of these three things to happen. Either it receives new props or we set state. Both of these will occur usually almost right away if we fetch data from an API. If we made an API fetch call in component did mount, while that is fetching, we move into our updating phase. When that data comes back, we either get new props or we get new state. And so almost right away, if you made that API call, we're going to go through the updating phase. And they both go through similar steps. Get derived state from props is called if you get new props. But then both props and state call this function, re-render the function, and then call this component lifecycle component did update. So what that looks like is, let's say we have a button to add. Let's go back to our to-do list. We've got a button to add our new to-do. We click that button. It runs this .set state, right? So our set state call gets run, and the first thing that React will do will say, okay, I'm going to run this function here, and I'm going to make sure that this component should update. And then if this returns false, it'll just stop here and go back to our updating phase. If this returns true, it will re-render the component with our new state. And you've seen that happen. We click the button, and our to-do list gets a new to-do added at the bottom of the list. And it re-renders our page. Then it goes through these couple things here. and then it runs one more function after all of that happens. And this is a way for us to check what new props or what new state came in, and run some more code if we need to based on the new data that just happened. So let's say we've got like a counter application, and every time the count number in state reaches number divisible by 10. So 10, 20, 30, 40. Every time it reaches one of those numbers, you want it to skip that number. So what would happen is when you click increment, it would go from 9 to 10. It would run set state. It would re-render, and then it would run component did update. Now inside component did update, you would say, is this dot state dot count divisible by 10? If it is, increment one more time and set your state one more time. Then it would set state one more time, re-render, check this. On the screen, you would end up with the number 11 instead of the number 10. So you can check your new data and run some logic based on what your new data is. A really good use case for this, really good example, is when someone logs into a site, that web application receives their user object, right? So you get a user ID. A lot of times, component did mount will check to see if you have a user ID or if your user ID has changed. And then if it has, they run a new data fetch for that user's whatever data they have for that user. So that's one use case that you'll see for component did updates. Okay, that is the lifecycle. The last thing that happens is when a component dies. This is the cleanup phase. And this is to clean up any event listeners or subscription. Event listener, ... or subscription. So if you need to have an event listener set up, you would set it up inside component did mount, and then you would remove it inside component will unmount. If you don't do the cleanup phase, then you get what's called a memory leak, and every time your component remounts, you're adding a new event listener and never removing any event listener. So if your component, if you're going from page to page and back to this component over and over again, like 15 times, if you've mounted this component 15 times, you'd have 15 different event listeners on that same node. And eventually, your browser would crash because it's trying to do too much. It would be too heavy on your browser, and that's what we call a memory leak. So you have to remember to clean up event listeners that happen that you set up in your component event. Okay, I'm going to check out Slack, and I hate that. I always keep drawing. There we go. Okay, so let's check out some of these questions. Can you explain specific examples of when to use component did update over component did mount? Yeah, we're going to look at all this today. So don't worry, we will get into that. Render should also be pure function, meaning it returns the same thing as stands. Okay. Yeah, I think we got to a good understanding point there. Can you update as many times as new data comes in, or should you just run it once and unmount and remount so you don't focus on one piece of data? You should update. You shouldn't be unmounting and remounting. You should be updating and re-rendering. This is a lot more performant because inside this render phase, when React updates the DOM and the refs, it will it will check which nodes have updated, and it will only update the proper nodes on the DOM. Whereas if we're unmounting and mounting over and over again, it's redrawing the entire component every time you mount. But if you use component did update, even if your data changes all the time. This is why something like an input works, where we can run this.setState on every single keystroke. We're running the render function over and over and over again. And if they type faster, it's rendering faster and faster, right? But it works because inside this update block right here, React knows only to re-render the text inside that input. It's not going to re-render the entire component or the entire component tree. So that's a really good question. Definitely rely as much as you can on update rather than remounting. In the to-do app, did we have memory leaks because we weren't using component will and mount at all? No, we didn't, because we weren't setting up event listeners inside component to mount. So that's a really good question. Let's do this real quick. There's a difference between event listeners and component and React events. So yeah, let's pull this up. And we're going to pull up our shopping list. And let's take a look at the events that we have in this component, in this app. And then we'll talk about what an event listener is and how it's different. So inside here, we've got our form. This is a good place to look at an event listener. So let's go to our form. Or not event listener, React event. Okay, so on our form up here, we've got this input. And we have this button. So in this form, we've got an onSubmit event handler and an onChange event handler. On our item, we have an onClick event handler. These event handlers are all different. These are not event listeners. These are event handlers. So we don't have to clean up any of our event handlers from something like this. An example of a React event listener . Let's see. So let's take a look at, oh, look at this, all Chinese. So something like handle resize is an event listener. So inside our component did mount, let me zoom in here. Inside our component did mount, we do window.eventListener, and we listen for the resize event. There's not an event handler in our JSX for the resize event. So we have to add our own event listener. Every time that the window is resized, it's going to run this callback function here, which sets some state, which gets read right here. So this is an event listener. Because you ran window.eventListener, you have to run window.remove event listener and pass in the same things right here. So this is an example where you have to add an event listener, custom event listener, not a React event listener, and then remove that in the component will and mount cleanup phase. All right, so should component update returns false if, say, the data has changed in state or not currently? What about children? Other cases for should component update? You don't really use should component update that often. The only time that it would really be appropriate, so if you return false out of component should update, none of the children components would even go through the render phase. For example, looking at this, if this function never gets rerun, then Pokemon, the Pokemon component will never get re-rendered either. So I personally have never run into a case that I've used should component update, although there are some slight performance optimizations you can use, you can make using should component update. One example would be, let's say you have a user object. So just think of some set of data that if an API call is made and some additional data comes into that data object that a component is looking at, you can check the specific fields that that exact component needs to know and all of its children need to know. And if none of those have changed, then you can return false out of component should update. Usually that happens if you have like two separate component trees on the screen at once, and you want to update one, but you don't want the other one to run through the whole updating phase. It won't update the DOMs on, or the nodes on the DOM, but it will still rerun every function, and it still takes up some computing power. So that would be one example that you could use should component update. Just not even look, not even rerun those functions on that one side, but run them on the other. Hopefully that wasn't too confusing. So we don't have to worry about running cleanup too much as long as we're using React synthetic events. Absolutely. Yep, that is absolutely correct. Again, if it's an event handler, don't worry about it. If you will know to run cleanup because you will have to do this in componented nodes. So if you do this, or any timer functions, if you do this dot set this dot set interval that just runs on a 1 second interval and does something every second, you set that up in componented mounts and you clean that up in component will on mount. Good questions. Yeah, I think the level of questions here is showing some good, already good understanding of what we are learning today. So when you're building out a project, it's good to keep in mind what's happening at each phase of the component lifecycle when you have that component, especially when we start fetching data, because that adds a new complexity to our applications, because you kick off a function and then there's a period of time before that function finishes running and finishes updating and setting state and all those things. So it's really good to kind of to start thinking about the life cycle of a component as you're building out React projects. We're going to start today with this project here from yesterday, and we're going to take a break right now, and then we'll come in here and we'll see these component lifecycle, the lifecycle and the methods in action in this Pokemon app. So we'll see you back in 5 minutes. Alrighty, come on back to your seats. Wait one quick second. Okay, what we're gonna do is, I posted this a couple times. The project, I shouldn't call this starting project, I'll just call this sandbox. The reason it's not our starting one is I forked off of our starting one, which is mentioned here, and it's a different sandbox ID. So this, if you want to come back later on another day, rewatch the lesson and start from the fresh starting point, this is where you would do that. This is the one that we will finish with today. Also, let me run live. No, not this one. This one. Here. Also, we'll have this link that we're going to be going off of here. So not to be confused with the other millions of links that we drop here. We'll have our notifications. Welcome, 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 welcome. And we'll go to classroom. Cool. So what we want to do here is demonstrate how lifecycle methods are working within this particular application. And we're going to demonstrate the timeline of this by making use of our console logs. So first of all, go to app.js and let's look at this. What is going to be the first method, the first lifecycle method that gets run inside app.js? The constructor. Yeah, so let's do this. Inside your constructor, I want you to do console.log constructor running. Okay, and what we should see is that our constructor gets run here. Awesome, so our constructor runs. What is going to be, after our constructor runs and we update our state, we set our initial data, what's going to be the next function that runs? The render function. Nice. So inside your render function, we're going to console.log rendering app.js. All right, so let's check that one out. Okay, and this is exactly what we expected, right? Our constructor runs first, and then we render app.js. And let's go see where this is coming in. And I think this is coming in Pokemon. Right here. Perfect. So in Pokemon.js, let's not console log props anymore. Let's console log Pokemon.js rendering. Okay, perfect. So we get our constructor. Our constructor runs. Our render function runs, which renders our Pokemon component. And so our Pokemon component renders. What would happen after render if we're still in the mounting phase? If we're still in the mounting phase, what's going to happen after render? Yeah, component did mount. And you'll often see people in the industry to shorten it to CDM. Or component did update, CDU, etc. Okay, so let's implement a component did mount function. This is going to have the same structure as our render function or constructor function. What I mean by that is we're just going to say component did mount like that. And right inside here, let's just console.log component did mount running. So now let's see what happens. So right in your component did mount, console log CDM running, and then we'll go through the steps. Looks like most of you have done that. Okay, so we've got component constructor running, step 1. Step 2, we're going to run the render function, which renders our Pokemon, which will run this console log. So these are both render functions before both of these components will render before we get to our component did mount. Once both of those have rendered, then we have component did mount. So let's do this real quick. We're going to kind of talk about what is happening inside each of these functions. So constructor. The job of the constructor is to initialize data and then also bind functions if you're not using arrow functions. And then one important part here is that this runs one time only. Then constructor runs. Then we get to our render function. The render function renders things. Surprise, surprise. This function will run many times in a component's lifespan. We shouldn't say will, it says can run many times. Then, after the initial render, CDM runs one time only. So those are kind of the steps that happen there that we talked about in this graphic here. All right, so what happens if we had some data that we were going to be fetching inside component did mount? We would run our fetch. We wouldn't be able to initialize our data here, right? So we don't have our data available to us. We're pretending that this is coming from an API. So I want you to change inside your constructor, I want you to change this data set to an empty array. And then inside component did mount, we're going to set our state for our Pokemon data. We're just going to set it to that data that we imported here, pretending that we actually made an API call for it. So we're going to run this.set state. We're updating Pokemon with the data that we are importing from that data file. So this is what component did mount looks like. Fetch, perform initial data fetches here. update state with the fetched data. So our fetch comes back, and then we set our data to our state. Now, you'll notice, you may have noticed already, that we got some extra console logs down here. What are our extra console logs after we ran this.setState? What happened here? Why did we get more console logs here? Yeah, we re-rendered. Exactly. So what happens when we re-render? Oh, perfect. Set state forces a re-render. Nice. So let's take a look at this at our chart here. We ran component did mount. We saw that happening right here, CDM running. Inside our component did mount, we sudo kind of fetch data. When that data came back, we set our state with our new data. So before that data came back, we jumped from the mounting phase to the updating phase, and we ran set state. When set state runs, we re-render, we run our render function again, which means that our app re-rendered and our Pokemon component re-rendered. So both of these console logs got called because both got re-rendered. So good job noticing that once we run this.setState, we're re-rendering both of our components. Now watch this. You don't have to follow along, but let's just, in our grocery list app here, inside our render function, I'm going to say rendering. Okay, so it happens once because of our initial render. Now, if I start typing, why is it not re-rendering? Oh, I know why. Our data is stored inside here. So let's run this one. Console.log. This is another reason that it can be good to hold things like your form state on its own component. As you notice, we didn't re-render our entire app and force our entire app to go through that render phase for every keystroke. So let's do rendering form. So for every single keystroke, our form is re-rendering. So this function is being called over and over and over and over and over and over again. React does a really good job of optimizing this, but again, if it turns out that that is too much for your app, especially if you have users that have slower computers or older computers, then using an uncontrolled component may be a good way to optimize that, rather than forcing a re-render on every single keystroke. Most of the time it's fine. Most of the time you should use controlled inputs. Sometimes you may need to use an uncontrolled input. But kind of crazy that is every single keystroke that is re-rendering the component. Okay, we kind of skipped one here. We haven't done anything with componented update. So let's do this. We're going to write component did update like this. So go ahead and add component did update to your app. And then we're going to talk about component did update. It's really hard for us to find a good use case right now for componented update with the type of apps that we're building. Next week, we're going to see some better use cases for it. Okay. Componented update is a little bit different than all of our other other lifecycle methods, in that it's actually going to take in some arguments here. So the two arguments that we're most concerned with are previous props and previous state. As I mentioned before, when we get to this point down here in the component lifecycle, we usually want to compare our old. Well, we get down to this point because we received new props or we received new state. So the logic that we do in here will run based on the new props or the new state that we got into our component. And so we have to check the new data that we got in against our old data. For example, most of the time in a componented update function, you'll see this kind of structure here. If preprops.user ID is different than our new props, let's see, this is this.props.user ID, then do something inside here. Like maybe we fetch user. Maybe we have a function called fetch user, and we pass in props, this.props. Okay, typing is hard. User ID. So this is the kind of structure that you'll see. You're going to compare our old data against our new data, and if it's the user ID prop that changed, then we fetch this.user. If it's something else, we don't want to run this.fetchUser. We don't want to run fetch user on every single update, every single time that we go through this flow right here. So componented update usually has this kind of a check, and then we'll, based on which props changed, we'll do some kind of logic. So let's check out this. We're going to console.log. We're going to say componented update running. And then we're going to check inside here. We don't have props.userid, so this console log will never run. All right, so let's look at our current list. Our constructor ran. We rendered both components. After that initial render, componented mount ran. It runs this.setState, which means we re-render, and then after setState, after the render, so this.setState, render, we finally hit componented update. And we see that right here at the end. And then finally, this didn't ever happen because this ended up being true. Undefined is the same as undefined, as it turns out. So this does not, this didn't get run. But if you have a user ID and it did change, then this code inside here will run. So a lot of times you'll see like 3 or 4 of these if statements, because you're always trying to solve for all the different possibilities of data being fetched and user interaction, this happens. And so you've got a lot of scenarios inside big applications that you need to check for changing data and do something based on that changing data. Checks for changing data lets us do something based on the data that changes. Okay, let's check out questions again, and then we'll take one more quick break. And then we're going to build a new app that actually will fetch some data from an API. And we're going to walk through this process one more time. All right, am I understanding this correctly? I know this was a while ago. Thanks for your patience, Spencer. Am I understanding this correctly? There are 3 important stages, which are mount, update, and mount. That is correct so far. Basically, mount phase is when an instance of a component is created and inserted into the DOM. Yes. Constructor, render, component mount will be called. Correct. Second phase, update phase, which when state or props get changed, render and component run. Correct. So when state changed or given new properties, render or component update is called. Yep. And then finally, component will and mount is when a component is removed from the DOM. Example, delete a counter, like you said. Yeah. So if you have something like a set interval, there was an app that I made that was a point of sale system that connected to a credit card machine. It was actually really cool. So the user behind the counter clicked a button that said like run credit card or something. And then their customer would slide their credit card, and my web app I ran a set time, a set interval, and every half second would check to see if the credit card, the steps on the credit card machine had gone to the next step. So every half second it was communicating with the machine to see where the customer on the front side of the counter was at with the credit card machine. So since I had that set interval running, then when the process was done, whether it was there was like 5 different outcomes. It could have timed out. They could have run a successful payment, unsuccessful payment, canceled the payment. There was quite a few different scenarios in that interaction. As soon as one of those scenarios happened and the employee behind the counter running my app, so my user, closed down that point of sale modal, then in component did unmount, I had to remove that set interval counter. Otherwise, that timer would keep happening and keep firing that function every half second. So yeah, that is the cleanup phase that we talked about. Does set state automatically force a re-render? Yes. Or does React check whether a re-render is required via component should update? Ooh, let's do this real quick. React does not automatically check this. It will automatically run this, but you have to do the check. So sorry, that was probably a little confusing. Let's not let this component ever update. So we're going to say should, is it component should update? Oh, should component update. I've never used this one, so I'm not used to typing it. I'm sure this one takes in brief props and state as well. In this function, we didn't really use brief state, so we would normally delete that to look like that. So let's just say return false. We're never going to let this component update. So let's do this. Console.log should component update is blocking renders. So what happens? Constructor running. We get our initial render with what is our initial data? With an empty array, right? So both of these run, then component did mount runs and sets our state. So, but we don't see our data. That's because before we could re-render, before we set our state, before we could re-render, we returned false out of ship component update. And ship component update blocks that render from happening. We could do a similar function inside this. This component here, our list component, if we copied and pasted that code here, we would never see our item state update. We would never see our text update here because it would just block the re-rendering of that component. So that is a good question. You have to do this manually. If this isn't part of your inside your class, then it will always just go through the render phase. It will always hit the render function and hit component did update. So oftentimes, if you see this, it'll probably be something like if prev props dot some object dot some property is not different than this dot props dot some object dot some property return false. Oh man, okay, it's gonna block me there. Or if they are equal, return false. Why are we returning false in both? This is. I don't know why that's happening. Oh, because you have to return true outside of it. Okay. Yeah. Cool. So don't forget, if you do use should component update to return true and, outside of your if statement. Cool. Good question. Let's see. So it's like calling Bulbasaur back into Pokeball, old props, old state, and sending out a new Pokemon, Charmander, which is the new prop and state, or keeping the same state but changing the props, like removing Bulbasaur and calling new props, which is Charmander. Yeah, so if this was like more of a game app and we wanted to battle some Pokemon, then we click on a battle button here, and we would render a component that has Bulbasaur passed down to it as a prop. And then if we click on Charmander, and that component received Charmander as the new Pokemon that we're battling, we could check to see if our Pokemon is different. We don't have to unmount that battle component. We just check to see if they're different, and then we run this dot set state with our new Pokemon, or we, I don't know, we update our whatever we want to do, whatever logic we want to do inside here with our Pokemon. Cool, I like that example. All right, let's take our last break, and we'll come back and we'll build out a really simple app that is going to actually fetch data. So you will see a data fetch today inside our component did mount. Alrighty, let's finish this up. Before we build our own, I wanted to show you this kind of cool project that I found that basically maps earthquakes that have happened based on a date range that you give it. So let's look at the last week. Click to date inputs and run submit. I think, oh, let's refresh. Let's start anew. Is this making, what is the data fetch? Let's see. Where's the data fetch here? Ah, stop it. I think I saw it right. Anyways, let's try something like just the last 2 days. Let's see if we can get this to change and re-update. Okay, nothing the last 2 days. There we go. So a few earthquakes in the last 3 days here. Anyway, so you can see that when our data is changing and we hit submit, the map re-renders. So let's change this to the full month. And then our map re-rendered again. None of this is re-rendering. I don't know why they need to re-render the actual map. I think they could just re-render the points on here. But anyways, so let's take a look at the code behind this and see if we can kind of decipher. There's going to be a lot more than we've looked at before, but we're just going to see if we can kind of decipher what's happening based on the lifecycle method. So we're going to start at our index.js. We're rendering app. So we're going to go into app. Now, piece of advice when you're looking at someone else's project, if you want to understand what's happening in the component, the first place I go to is the render function. I find what data is being used in the render function. I find what components are being rendered. And then I can know what to look for in the project or in that file itself. So we're going to go to earthquake container. That's this file here. So I'm going to go down to the render function. And okay, a lot going on here. So we've got, not too worried about these. That's just this bottom stuff down here. What I see up above this is we've got an earthquake form that's using this.onFilter. So we'll have an onFilter function in this class. We're using earthquakes map and passing in props.google and this.state.quakes. So let's go look at our state and our props. Since we have props and state happening here, and this is on filter, I think we can assume that this is going to run set state. We should be able to see some lifecycle methods in action here. So here is on filter. So we do, this is setting state based on an API call. So eventually when we search for earthquakes with that date, those 2 date pickers, the data will come back and we'll set our earthquakes, our quakes state with whatever that API returned. So when state updates, we're not doing a component did update. Okay, so all that happens is we just pass that into earthquakes map. So we'll go look at earthquakes map in a second, but let's check this out. So we don't have a constructor. If you don't have a constructor, but you still want state, you can do this pattern here, and React will run the constructor for you and initialize your state with this object. Okay, so it gets initialized with no earthquakes, just an empty array. Then we fetch our quakes, so we run our initial data fetch. When that comes back, .then, we set our state with our newly fetched earthquakes. So there's component did mount, it runs that initial fetch, and runs set state. Then when we filter, we're updating our state. So let's go into earthquakes map here. And let's check out the render function. So this has a reference, which this function here, let's find where map ref is going to grab that reference. This is kind of how you have to do Google Maps. You have to use that reference. It should, let's see, it should say to put this map on that map reference. This dot set map. Yeah, anyways, we don't have to worry about this map function too much. But look at this, we've got component did update. Takes in previous props, takes in previous state even though this person's not using previous state. So let's look at this, component did update. If the props, this.props.google has changed, if our previous props is different than our new props, or if our previous earthquake data is different than our new earthquake data, we run this.loadMap. And loadMap is what generates that map, and then inside this loadMap function, you get all the points of the earthquake from the data, et cetera, et cetera. Google Maps are really fun to work with. They take quite a bit to understand what you're doing, but it's really fun to work with. So every time that we get that Google Maps is ready, or we update our earthquakes data, we're going to run this.loadMap. And that's why when we run a new query here, the whole map disappears and then reappears like that, because you're just running that new that load map function every time you get new data. Do you guys want this link? I assume you do. I'm just going to post it for you because it's a really cool application. All right. Let's open up a new sandbox. And I'm going to close down the live for this session. I'm going to go live on this session here. And I'll just close that. Okay. So right there is the new live session. Perfect. This is what we're going to do. We're going to use the Doggo API. We're going to fetch some images of dogs. So let's first change our app into a class. When we do that, we want to wrap our return inside the render function. Then we're ready to roll. Now you'll notice sometimes that you get the wrong thing rendered here. If you just refresh your browser window, then it should sync up. Okay. Yeah, I'm connected again. Let me know if that refresh did something weird to the live link. All right, so what do we want to do? We want to have a state object. Oh, I joined the live, but it won't let me update. That is weird. Okay, I need to shut down. I can't shut this down. Okay, refreshing when we're live is a bad idea, folks. I'm an owner, but I'm also a viewer. I don't get it. Okay, good. I'm back as the owner. Okay, good. All right, weird stuff. If I type in here, can you guys see the edits in your live session? Cool. All right, crisis averted. So we're going to add a state object, kind of like the earthquake app did, outside our constructor because we're rebels like that. And we're going to say doggos is going to be an empty array. And for our doggos, we're going to render this. Let me pass this on to you. That's awesome. Okay, so throw that inside your app div. Like that. Oh, this is supposed to be hello doggos. Okay, so we're rendering a map of doggos, but we don't have any doggos yet. So we need to run component did mount to fetch our doggos. And we could do kind of a similar exercise here where we console log everything. So let's do console.log CDN. We can do console.log rendering. Okay. Then, if we had a constructor, we would console log in our constructor. Perfect. All right. Next, we want to actually fetch our data. So I will give you this code here as well. So grab that, and you're going to put it right under this console log, like that. Bum-ba-dum. And then you should get your doggos. You should get your Malinois. I don't know how to say that. Doggos. Woo! It's working. It's working. All right, so that's awesome. This you can change the breed and get a new breed. You can see the images there. One thing we could do is build an input to control, to fetch a new set of doggos based on the breed. So we could make this fetch call be our initial fetch call, and then you type in a new breed, and it makes a fetch call for a new set of images. So let's do that real quick. Inside hello doggos, right under hello doggos, We're going to add an input. Type text, and for some reason that didn't close it. That's weird. And let's control this value with this dot state dot doggo text. Okay, so we actually need our doggo text, right? And then if we did something like husky, we should see that controlling our input. Okay, we kind of know the routine here. We're going to have it on change, and it's going to be this dot handle changes, and everything is dropped down. So we're going to have a handle changes function that takes in an event, runs this dot set state, and we don't have a name on here, but we only have one input, so I'm not too worried about doing hard coding doggo text right here. Okay, let's take away husky. And why are we not handle changes? Doggo text, e.target.value. We should be able to type this now. This dot state dot doggo text. Text. Anybody see what I'm doing wrong? Arrow, oh, bind, yes, thank you. Ha! Arrow function. You guys are awesome. There we go. Okay, so we've got our input working. Now, let's add a button that we're going to call fetch doggos. And this will have an on-click handler that runs this dot fetch doggos. Fetch doggos will take in an event. And we're going to run event.prevent default. And then we're going to make a new fetch. So we're going to take this same fetch code here. We're going to make this an interpolated string and pass in whatever our state.doggo text is right here for the breed. So let's make this an interpolated string. We're going to say this dot state dot doggo text. Now what should happen is we should be able to type into here and fetch our doggos and click fetch doggos. It will run this code. When the call gets back, then it's going to run set state, and we're going to add our new doggos to our state for doggos. So we should be able to do something like this. Hit fetch, and there we go. There's our new dogs. Let's go see what some other breeds are. So breeds list. And these are all the breeds we can do. So let's try blue tick. I like blue ticks. Oh, there It's not on submit, it's just the button. There's our blue ticks. Cool, so that's pretty awesome, but we haven't really used component did update to check new data that's coming in. So let's do this. We're going to set up component did update. Now this usually happens, your constructor and then your lifecycle hooks like component did mount and component did update are usually at the top of your class, and then custom functions that you write are below that but above the render. So we're going to do component did update. And we're going to look at our previous state. So we do need to add previous props, previous state. We're going to say if previous state dot doggos is different than this dot state dot doggos. So if we just updated if we just made a new fetch, whether it's this fetch or this fetch, then we're going to check our doggos. And if our doggos have changed, we're going to say this dot if this dot state dot doggo text equals, now we got to find, let's see, let me comment that out for a second. Let's find a dog that we don't like. Let's say Chihuahua. We don't want to ever see pictures of the Chihuahua. Equals Chihuahua. Is that spelled correctly? Chihuahua. So if our doggos have changed, and if our text equals Chihuahua, then we're going to refetch, and we're going to say back to our Huskies, because Huskies are cooler dogs than Chihuahuas. So let's do this. We'll go through blue tick. Well, let's console log through this whole thing. Console.log, component did update, running, console.log, doggos have changed, console.log, ew, it's Chihuahua. Okay. So there we go. We ran our component did mount. We re-rendered. We ran component did update because we got that first call in, and our doggos have changed. We see that right here, but it's not a Chihuahua. So let's try blue tick. Okay, so component did update, ran, we rendered, doggos have changed, but we keep our blue ticks because it wasn't Chihuahua. Let's try Chihuahua. All right, so what happened? Stop it. Oh, it's running over and over and over again because Chihuahua is still up here, and our state is changing, so it keeps running that. So let's do this. When we hit fetch doggos, we're going to set our state and clear out our doggos text. That is one of the many issues and complexities of this kind of a situation. Componented mount, componented update, we're doing all these deep checks, and you notice that it just kept running and kept refetching, kept running and kept refetching. Now, if we do chihuahua and hit fetch doggos, is it still doing it? Okay, doggos text should have cleared out. Let's see this in the browser. Refetching. Our network. Fetching, 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 fetching. 450 requests. Huh, interesting. I'd have to do a little bit of digging to see. Oh, you know what we could do? We need to run this right here inside our componented update. So we do need to update our doggo text inside here, and that should stop that from happening anywhere. Nope, still didn't. I'll see if I can figure out why this is happening. Point in case for this is an excellent example for something called React hooks. Yay, React hooks. The use effect hook replaces componented mount and componented update, and we would not run into that same issue. So that's awesome. Yay, group chat. All right, cool. Let's check out Slack. Oh, darn it. Okay. Thank you. My sound is off and I didn't get these notifications. But still, a really good point in case for why you should learn hooks. So let's do, I was wondering why the heck that wasn't, wait, no it didn't. Doggo text, doggo text. Oh, it's doggos, plural. I see what you're saying. Okay, try this again. Chihuahua, doggos. Ah, now it's not updating. No. Use hooks. Okay, cool. So weird. I'll take a look and see if I can figure out what the heck is going on there. Awesome, awesome. Uh-oh, did I do it again? Yes, we had to kind of hustle through that last example. All right, so let's go look through questions. So a way we might use this is if we instantly locally add an update to a component so as to provide a natural seeming confirmation that the data was applied, and then send the data back to the server. Then the server makes a noise back when we get data back about how the data has changed. We might use component should update to affirm. No re-renderings. And if we didn't already send the data, we might use component update to respond the message. Yeah, and again, every situation, as you just saw, even in a very simple application, every situation is going to get pretty complicated. And hooks really are going to clean up a lot of that complication. It takes away so much of that complication. I mean, I've done this kind of a pattern many times in my career, and I don't know why this is not working? We can type in Husky. What if we type in Chihuahua? Doggo text, doggos. It should, by all accounts, update. But we didn't see this. I don't know, maybe something is spelled wrong here. Anyways. So yeah, everything, this is a great look at and a really good example of, again, this is the process of how this all happens is complicated. And so learning and just knowing this flow is very important. Can you please repeat where you got the data from fetch.then.catch? Next week, yes, we will learn this next week. That's why I handed you the code right here. So Wednesday and Thursday next week is all about data fetching. That's what we will do there. Let's see. Yeah, I'm going to do like a after hours or weekend lecture for you guys specifically on hooks. So you will get, I will teach you the hooks, the ways of hooks. Let's see, target text. Ah, okay. Wagner's got it. Yeah, I think that's what's happening. Cool. Yeah, I don't know what that's going to look like, but now that you have seen component life cycles, you're now ready to learn about hooks. So I'm not sure when I'm going to have time and when it will work well with the class, but it will come. Okay, I'll look into this because yeah, something like this is happening. So the input is happening before the fetch gets back, which means this no longer happens. But yeah, I'll see if I can figure that out and I will message you guys. Okay, let's take a look at the project, what we're going to be doing for the project today. Project, there you are. Alrighty, today is, as far as component lifecycle stuff goes, very light. So use lifecycle methods. These are your tasks for today. In app.js, use component did mount to set your data to component state. Use the state object to pass data to your post container component. That is all you have to do with lifecycle methods. Nothing more. The best example you have is right here. You're importing data from another file, right? So instead of just doing Pokemon equals data, or posts, however you have it on state, set that to an empty array, set up a component did mount, and do that instead. So that right there completes that objective for today. Now the rest of this gets more complicated. This, you have to rely a lot on your JavaScript knowledge and skills. So you're going to go through adding a comment in your comment section. You're going to implement the ability to like posts and implement the ability to search your posts by username. So this is just a lot of JavaScript practicing. There are steps to walk you through it. This one is a little bit more hand-holdy than maybe these two are, but we want you to be practicing your JavaScript a lot because React requires you to be a really good JavaScript developer. So you get lots of reps here today. Again, tomorrow we're going to be doing some weird stuff with higher order components and cool stuff, but different And then Thursday is kind of a catch-up day for everything. Okay, I'm just going to double check, make sure we got all our questions, and yep, looks like we're good. So have a great day, guys. I will see you tomorrow. Remember your 20-minute rule. Struggle for 20 minutes before you reach out on the help channel or to your PMs. And yeah, I'll see you tomorrow.